Hello guys, I'm back with another video. In this video, we are going to see the working of Docker. It's not going to be a surface level video. It's going to go through the entire working tree of Docker, how the architecture works, how Docker exists inside a virtual machine in Mac and Windows, and the networking inside Docker, and the configuration file of Docker daemon. So let's get into the working tree flowchart of Docker. So this is the tree that I've created for Docker. And here you can see Docker can run on Linux directly, but it can't run on Mac or Windows or any other operating systems because it doesn't have the features that Linux have, such as C groups and namespaces. So for mitigating that issue, Docker's gonna create a virtual machine inside your Mac, or so that it will create a virtual machine based on Linux, so that the namespaces and the C groups can exist inside this VM and Docker can access it. So firstly, we are gonna log into the virtual machine. So you can see here, this is the command for logging into the virtual machine. So you're gonna create the Docker run privilege, and the process ID for this particular container will be the same as the process ID of your virtual machine. So everything that's inside the virtual machine is gonna appear on this Docker container. So I'm just gonna run this on my terminal. Yeah. And boom, we are inside the Docker virtual machine on our Mac. Let's see what's inside. So these are the directories inside the virtual machine of the Docker VM inside your computer, inside your host Mac. So let me just go to the working tree. So yeah guys, so we have covered the first process here, which is getting inside the Mac OS virtual machine. So inside the virtual machine is the Docker daemon. So Docker daemon is not running on your Mac. It is running inside the virtual machine that Docker is created for you. So this is the Docker daemon, and let me just go to the next level, which is the Docker VM. So inside the Docker VM, we are going to have four main things, which are the Docker daemon, the container runtime, the low-level runtime, which is runc, and the Linux kernel. So firstly, let's look at what Docker daemon is. So yeah, this is the Docker daemon. So Docker daemon is going to have three main functions. Firstly, it's going to act as the API server, and second, it's going to act as the image manager, and thirdly, it's going to connect with the container runtime for creating the containers. So let me just go to the API server here. So how does this Docker daemon going to interact with your Mac? Your Mac is running outside the virtual machine, and inside the virtual machine is your Docker daemon. So when you type docker ps, let me just go here. Let me just create another window, guys. So in your current Mac, when you type docker ps, it's going to show you the containers that is running, but the main Docker daemon is inside VM. So how, when you type something on your Mac CLI, it's going to reflect inside the Docker VM here. So that is because of sockets. So inside Mac, we are going to have the sockets inside this directory. So let me just go to my Mac, and here's Mac, and let me just go to the root folder, and let me just see the where run, I think, yeah. So here, yeah, see guys, here is the Docker socket on our Mac. So this is the Docker socket that is located on your Mac. This socket is going to help us to connect to this virtual machine of the Docker. So whatever you type inside the CLI of Mac, it's going to appear inside. It's going to send it to the socket to our Docker virtual machine. So that's what this Docker does. So after that, so the command that is typed on the Docker CLI, it's not going to send us docker ps through the socket to the socket located inside the virtual machine. So that's not going to happen. the Docker PS is going to get converted into a HTTP request, which means there's Docker API inside Docker. So whenever you type Docker PS, it's going to convert that into a HTTP request API endpoint, and that endpoint is going to hit on to the Docker socket that is located inside your Docker virtual machine, and the daemon it's gonna process that request and give you the answer inside through the socket to appear on your Mac. So yeah, the Docker daemon is here based on this image, and which is the server, and the REST API. So the Docker daemon, it's gonna use the REST API to make the request processed. So CLI, in the CLI, we are doing the PS command, and the PS command, it's going to convert it into the HTTP request, and that request is going to be sent into the Docker daemon. We can do this in our terminal itself. Let me just copy this. So yeah, here. So let me just go to my root directory and let me just clear everything else. Yeah. So I'm just gonna paste this. This is going to be the exact output we will get when we do Docker PS. I'm using curl to connect to make a request to the socket, and yeah, you see, yes, yeah, just in a center for entering to the virtual machine. So the container that I'm only running here is Redis right now. And yeah, so that's how here you can see the container that I'm running, Justin Cormac here, and where's the Redis thing? Yeah, okay, yeah, here, image Redis and the image Justin Cormac that I'm running. So it's basically a HTTP request that we are sending to the Docker daemon, and we are getting the same result as Docker PS. So yeah, that's how it works here. So this is the entire thing of the sockets, and here I have made an explicit thing, which is socket forwarding is independent of the file system mount. So what it means is, let me just go here. So whenever you create a virtual machine inside your Mac for Docker, it's going to mount some file systems in your Mac into the virtual machine. You can see it over here. So inside the Docker VM, you see the host mount thing. So inside, let me just see the inside to that. And you see, this is the exact users directory that I'm having in my Mac that is mounted into the virtual machine of Docker, which means if I change something inside the users, inside the virtual machine, it's gonna appear on my current Mac that is having the original file folder. So that's how mount works. So here, if the mount appears, the socket is also going to be mounted inside the virtual machine. So the socket that is located on your Mac is going to be the same as the socket located on a virtual machine, but that doesn't make any sense. How can you have this same socket on your Mac inside your VM? So the socket forwarding is independent of the file mount. That's what I told her. It's just a proxy for forwarding your request. So this is the API server function of the Docker daemon, and let me just get into the image manager of Docker daemon. So here. So firstly, what Docker daemon is going to do is it will check whether the image is, if you did something like Redis, it's going to check whether the image is located on the storage. If the image is not located on the storage, it's going to send an HTTP request to the Docker registry to pull the image from the registry and store it in the image folder. So basically, it also creates the writable layer, which is the unique layer that is present on your container. And when the image is ready, it will call the container runtime function. That's what Docker daemon does here. And so what is an image? So images will contain 4 levels. The first level is the lower directory, which is the a read-only layer, read-only layer base image of that particular image. So here we are having it may be an operating system, or it may be Ubuntu or something like that. And then we are having the upper directory, which is the writable layer, which is unique to each container, which means it's going to create a separate layer for each of the Docker commands that you're writing. So working directory, it's a temporary directory which is used for creating the overlay file systems. And the last one is the mount point, to which file system that you're going to mount the entire overlay file system to. So here the Docker daemon is going to only check whether the image is located on your machine. Otherwise, if it's not present, it's going to send a request to the Docker directory. But the union of the layers, which is the image layer and the writable layer and the other layers, the dependency layers, the stacking of these layers, it's gonna only happen in the container runtime. So the container runtime is gonna define the entire file system of the container. So Docker daemon is just fetching the image. So yeah, so what is inside the image? The image inside the image, we are going to have the manifest JSON, config JSON, which is going to have the env and entry point, the layer one, as I said before, layer by layer. Each layer is unique for each of the Docker command that you write inside your Docker file. So how can we see the images? Let me just copy this and go to our VM. And yeah, so yes, we are inside the image. So inside the image, we are going to have the overlay folder. So let me just go to the cd overlay 2. And yeah, inside the overlay folder, we are going to have these three things which are super important. The first thing is distribution. So let me just go inside the distribution folder. So yeah, inside the distribution folder, we are going to have two things, but diff ID by digest is an important one. So diff ID by digest means you're gonna get the image from the Docker directory as a compressed file, which is the digest. And the Docker is going to optimize this without getting the same image again and again from the Docker registry. It's gonna have that file in a form of uncompressed, which is the diff ID, so that the image can be reusable by other containers. So the diff ID is the uncompressed form of the Docker image, and the digest is the compressed form of the Docker image. So each is going to have its own separate hash. The diff ID is going to have a hash of its own, and digest it's going to have a hash of its own, so that it's going to create a map not to create any duplicates. Let's get inside the diff ID by digest. Yeah, so let me go inside the SHA-256. SHA-256, and yeah. So these are the hashes that has been stored inside the diff ID by digest. So it's just a series of hashes that are in the uncompressed form inside the Docker. So let me just go inside the root directory again. So yeah, that's just images, and that's how images source inside this one. So yeah, just a second. I think I just show you the diff ID and the overlay thing. Yeah, so there is another thing inside the overlay too, which is the image DB and the layer DB. The image DB is going to store all the images metadata inside the image DB, and the layer DB is the writable layers that is present in your image. So let me just go inside the image DB, and it's going to have the content and the metadata of the images. And if you get inside the layer DB, it will have the information about the mounts. Let me just go inside the mounts, and yeah, so each of the container is gonna have these are the container hashes that has been created by the Docker. Yeah, these the mounts will contain the initialization ID and the mount ID for the particular container, and also the hashes for that particular layer and the temporary folder for the metadata. That's what the image DB and the layer DB contains. That's everything about images. So yeah, the images will also have the config.json, layer 1, layer 2, and everything. So we can see this config.json in docker 01 folder, which is the main folder of the virtual machine. I will just show you guys it after this container thing. Just go to the Docker thing. Yeah, to the containers, and yeah, these are the containers that are present in our Docker. So let me just go inside the Docker container. So yeah, each of the Docker container, it's going to have a config file of its own, the host name, the host, the resolve.conf, which is going to be the DNS configuration for that particular container, and the mounts and all the file system inside the mounts. So let me just show you guys the config file that has been present here. This is the entire configuration of that particular container which is present here. So this is the Postgres container, and the image ID and the IP gateway for this particular container. So it's basically the configuration that the container is created based on that. So yeah guys, so this is the container. So let me just go to the root again, and yeah, we're good to go. So this is the container for the Docker thing. And then the last thing that our Docker daemon does is it will call the container runtime. How it's going to call the container runtime? It's again sockets. The Docker D is going to send, hey, I've created the image and the configurations for you. You can do your work. So it's going to send that message to the container D. So how we can see the Docker D, which is the daemon process that is running, and the container D runtime that is running inside our virtual machine. Let me just see all the processes that has been running inside this particular virtual machine. So yeah, here we can see 342 here. See here, this is the Docker daemon process that has been running, and the container daemon is running on 282. So let me just grab this one, here's awk, and grab the Docker D. So yeah, this is the Docker process that has been running inside our virtual machine. The Docker daemon, which is fetching all the images, which is connecting our current Docker CLI on a Mac with our virtual machine and everything. So let me just go, let me just show you guys the daemon file of the Docker daemon. Okay, here we have the daemon file, and let me just show you guys what's inside the Docker daemon. So inside the Docker daemon, it's just gonna have the default keep storage and everything, and the host and some general configuration files for the Docker daemon. So that's about the Docker daemon that is running. So yeah, the socket that Docker daemon is going to use is also present, I think, here. Let me just grab here, and yeah, it's using the socket from the container daemon, which is located on run containerd sock. So let me just one thing, I will also do the grep of the container daemon, And yeah, here we can see that the container daemon is running here using the socket file that is present inside the container. So the container.sock is helping the Docker daemon to communicate with the container. So that's it about the Docker daemon. And moving on, let me just go to the container runtime. So container runtime is going to have all these functions. Let me just go it over for you guys quickly. It's going to have the overlay file system, which is it's going to stack each of the layers that has been created from the Docker daemon into an entire union file system. And namespaces are used for isolating the particular container. Each of the container, it's gonna have its own process ID, mount space, UTS namespace, the inter-process communication, and the network namespace to isolate that particular process, which is that particular container. And C groups, which are control groups for CPU usage, memory limit, and input-output limits, and managing the lifecycle of the container, whether it's up, down, or running. And the networking configuration, so it's going to use the CNI plugins for creating the IP addresses for each of the containers. So after doing all this, which is creating the namespaces, overlay file systems, the control groups, the networking configuration of that, it's going to call the run C, which is the runtime of the Docker. So the container runtime is based on the open container initiative, which means it's a set of industry standards for creating a particular container. So firstly, here you can see the API core and backend. Each of the container is going to have its own images, namespaces, and snapshots for running it. And after creating that particular bundle of the container, it's going to send it to the runtime. So runtime is going to create a shim process for each of the container. So even though the container runtime is not working correctly or changing, the sim process of the container, which is, let me say that it's a Redis container, it will run independently without depending on that particular container runtime. So yeah guys, so that's what container runtime does. It will create a set of namespaces, overlays, and basically the bundle for creating the container, but the container is created by the runc runtime. Okay, so that's what container daemon does. Let me just show you guys quickly about the networking that's been created by the container daemon, container D. And here, this is the Docker virtual machine. So it's just a simple networking thing inside Docker. So each Docker is going to create a bridge network. So each of the bridge network is going to have one virtual router. So the default router is Docker 0. So it's going to create its own local area network inside that particular bridge. So Docker 0 is the bridge network, and it has container 1, container 2, and container 3, each with its own subnet IP addresses. So if you create a bridge called mynet, that bridge is going to create its own subnet configuration and assigning IP address for each of the containers that is running inside that particular bridge based on the IP address subnet of your virtual router, which is again created inside your bridge. So if I create a bridge, it's going to create a virtual router and a LAN and assign IP address to each of the containers working inside the LAN. That's what a bridge network does. So the virtual router, why we need the virtual router? So each of the container, when it wants to access the internet, let's say it's going to have an apt install and it want to access the internet, it's going to send the request to the virtual router inside the bridge, and the bridge is going to forward that request to the resolved DNS interface located on our virtual machine. That is the 192.168.65.7. It's like connecting to our home router based on the IP addresses given to our devices like mobile, laptops, and everything here the router is the DNS interface, and that DNS interface is gonna again forward to the Mac's original DNS, which is the host DNS, and then that DNS is going to get forward to our home's router and to the internet. That's how the internet gets accessed inside the virtual machine to the containers. So if I get any reply from the internet, it's gonna follow the reverse process, and it's gonna distribute to all the containers. So how can I see this particular DNS interface? Show you the config file from the Docker virtual machine. Let me just go inside the root directory, and let me just ls, and yeah, this is the original root directory of our Docker virtual machine. Let me just go inside the containers. Let me just go inside the services. Let me just go inside the Docker and ls. So guys, this 01/docker, it is the original Docker folder of the virtual machine that it's been running on. Here, let me just cat the config.json for you guys. So yeah, this is the entire configuration file for running the virtual machine on your Mac. So here you see the OCI version of it, and the arguments and the path that has been forwarded, and the main here is the mounting, how the mounting happens. So the source is your Mac, and the destination is the folder inside your virtual machine. So inside the mount section, it's gonna mount everything in your Mac, not everything, it's just the main folders, to the virtual machine following this configuration file. So yeah, that's how configuration file works. And let me just go to the Docker container resolve. So yeah guys, let me just again, I want to just show you guys what's inside. And inside lower, it's gonna have the base images, and rootfs is the file system for the virtual machine. The lower is the base image for the virtual machine. I'm not talking about containers, I'm talking about the Docker virtual machine running on your Mac. This is the files that helps Docker virtual machine to run on your Mac. So yes guys, let me just go to, guys, the Docker is located inside the vaglib, and I'm gonna get inside the Docker, and I'm gonna list the files, and I'm going to get inside the containers. Yeah, so let me just get inside the containers, and let me just list it, and let me just go inside the container. I think I already showed you what's inside the container, but let me just cat this one, the resolve.conf file, and yeah, let me just, yeah. So this is the DNS for our virtual machine for talking to our Mac host. So that's what it does. And what are these connections mean? So let me just show you guys in, let me just show you. So yes guys, when you type ifconfig here, it's gonna show you the Docker 0, which is the bridge network, and these are my own created bridge network. I haven't named it, but I just created for other projects. So this is the Ethernet that has been stored, and this is the vEth that has been allocated to each of the container. So each of the container is going to have the virtual Ethernet. Let me just say one end is connected to the container, and the other end is connected to the virtual router. So the vEth means it's going to create that particular connection between the router and the container. So that's what vEth means. That's what the connections over here means. So that's the networking part of the Docker. So let me just move on to the runtime, which is the last part of the Docker runtime. So yes guys, here is the Docker runtime. So what Docker runtime does is it's going to take all the config.json, which is sent by the containerd, and it's going to include all the details, create the namespaces using the set namespace system call. It's going to set the namespace, and each of the namespaces is going to have its own file system mounted and everything. So this container ID is going to send the configuration for the entire container, and based on that container, the runc is a sim process that is going to be created for each of the containers. You can see it over here. Each of the container is created, is having its own runc virtual runc sim function. So here the runc is going to interact with the Linux kernel, and that's how we are going to get the container. So yes guys, that is how the Docker works here. And let me just give you guys a glimpse about Docker volumes and Docker compose. It's just simple. You got the entire picture of Docker. So Docker volume, it changes the directory in virtual machine to Mac, which means when you mount a directory for volume, that directory is going to appear inside your virtual machine. When you change something on your virtual machine, it's reflective on your Mac's. When you forward it to your, you can just forward it to your Mac's file system, and that is going to be persistent on your disk. And Docker Compose is just a series of network configuration. You're just going to create a bridge network and put all the containers inside the bridge. That's going to create a LAN for you. So that's how these two things work. And yes guys, that is the entire overview of Docker, I guess. Yeah, I just covered the entire thing about Docker. So this is how Docker works internally. So it's going to have all these runtimes and container daemons, Docker daemon, and everything. So it's gonna pack everything and gives you all the freedom for working with your containers efficiently. So that's it for the video, guys. If you like the video, please like, share, and subscribe, and see you guys again with the next awesome video. Bye bye.